So, let us discuss some important and expected questions from the carboxylic acid derivatives. Number 1 question: which one of the following is the least reactive for nucleophilic substitution reaction? Options are given: acid anhydride, acid chloride, acid amide and the acid ester. Actually, this is the very important question of the carboxylic acid derivatives. Let us have a X here and treat it with a sodium salt of a Y nucleophile. This Y nucleophile replace the X and you will get a Y containing group. So, this is a substitution nucleophilic reaction at a acyl carbon, just like RX undergoing alkyl halides also undergo this type of reaction, but that is at saturated carbon. This carbon is called acyl carbon. So, reaction taking place on the acyl carbon, it is a characteristic reaction of the nucleophilic, the substitution reaction of the acid, the derivatives. In this derivatives, the first compound will be the acid halides, the second compound will be the acid anhydrides, the third compound will be the acid esters, and the last less reactive compound is acid amides. The nucleophile outgoing group is the X here, the X is here marked, that is halogen. In the acid anhydrides, the RCO group, acetoxy group. In the acid esters, it is the alkoxy group. Amides, it is the amino group. So, actually the outgoing property will be the number 1 in the halogen compounds, number 2 will be the acid anhydrides, number 3 will be the acid esters, number 4 will be this one. Because the stronger acid anion, the anion obtained from the HCl, HCl is strong acid whose anion will be the weakest base. So, the basicities of these 4, if you compare, this is the weakest base, then little stronger, NH2 minus is the strongest one and shows a very strong plus mesomeric effect, and therefore, it will not go out at all. Outgoing property of the NH2 will be least. So, therefore, amides will be the least the outgoing property, most reactive will be the acid halides. So, therefore, option C, acid amide is the right answer. So, let us go to the question number 2. In the given reaction, benzoyl chloride and acid chloride treated with the 1 mole of the methyl magnesium chloride, specifically mentioned 1 mole, and the X is formed. The X will be the compound that is asked here. The option A is a tertiary alcohol with phenyl and 2-methyl carbinol. Option B is a 2 phenyls and methyl carbinol. Option C is a methyl phenyl ketone. Option D is a phenyl methyl containing a 2-degree alcohol it is. So, specifically the reaction is theoretically totally it is a C6H5 with a C double bond OCl reaction with methyl magnesium bromide. It is a nucleophilic substitution reaction, first addition reaction takes place. So, the R will be added on the carbonyl group and the magnesium will be added on the oxygen. So, you will get a C6H5 when O minus comes back, the Cl will be replaced and you will get a equal to the nucleophilic addition reaction. Actually, it is a nucleophilic addition, but the Cl is replaced. Therefore, finally, it looks like a Cl is gone and a methyl has come, but this reaction is only a theoretical compound because he is asked only 1 mole of the reagent. In general, if it is nothing is mentioned, it reacts, or with specifically if excess is asked, once again the ketone reacts and you will get a tertiary alcohols actually. But in this reaction, the final answer is nothing but the ketone, that is option C is the phenyl methyl ketone is the answer. So, let us go to the question number 3. The question is, benzoyl chloride is less reactive than acetyl chloride for nucleophilic substitution reaction. Because of the 4 different the answers are given. A carbonyl group of benzoyl chloride is in conjugation with benzene ring. that is appears, but it is not the reason. The methyl group of acetyl chloride makes CCl bond stronger due to the plus I effect. C6H5 group of benzoyl chloride makes CCl bond weaker due to the plus R effect. CH3 group makes CCl bond weaker due to the plus I effect, and phenyl group makes CCl bond stronger due to the minus I effect. 4 options are given. So, what is happening here? CH3COCl is more reactive than the benzene COCl. There is a good resonance between this lone pair and the double bond. Because of this resonance, the benzene resonance will not be entertained with this particular carbonyl group resonance. Therefore, benzene, the effect of the plus M effect, or what you say the plus R effect, will not come into the picture of this the acid group or acid chloride. Only we have to consider is the methyl group shows plus I effect, and the carbon which is sp2 carbon shows a minus I effect. When it is minus I effect, the chlorine and the CCl bond is not going out fastly, whereas if you have here a plus I group, so it pushes the Cl out, so the replacement of the Cl will become easy. So, therefore, the benzoyl chloride is less reactive and the acetyl chloride is more reactive. Only inductive effect based the answer you have to give, but not the resonance effect in combination with the mesomeric effect of this and this you cannot club here. So, therefore, the last option, that is the answer D, is the right answer. Let us go to the question number 4. The question is, which of the following compounds gives carboxylic acid with nitrous acid HNO2? Option A is benzoyl chloride. Option B is a benzoic acid amide, benzamide. Option C is an acetic anhydride. Option D is a ethyl ester of acetic acid, ethyl acetate. So, here we know a fundamental reaction that aliphatic 1 degree amines. This should be aliphatic, and it is 1 degree amines. Will undergo reaction with the HNO2, will give the RN2Cl. But because of the plus I effect, the R minus I effect of this one, and this N2 will go out with a aqueous solution, water will be there. So, therefore, it finally becomes into alcohol. So, the 1 degree amines with nitrous acid will give the alcoholic. Similar the way the acid amides also will undergo the same type of the reaction, in which this NH2 finally becomes into RCOOH. So, therefore, only the acid amides will give the carboxylic acid, not all other acid derivatives. So, therefore, option B is the right answer. Let us go to the question number 5. Among the following compounds in decreasing order of reactivity for hydrolysis reaction. So, all the 4 compounds are benzoic acid derivatives, actually benzoyl chlorides are there, but the first option is simple benzoyl chloride, second option is a para-nitro benzoyl chloride, third option is a para-methyl benzoic acid, fourth option is para-aldehyde containing benzoyl chloride. In this question, all are benzoic acids, but in this benzoic acid chlorides, some group is there, the group influence on this one. Say a nucleophile is going to replace by attacking this nucleophile on the carbon, which is essentially a carbocation after polarization. So, if the group makes a strong positive nature, the nucleophile will be the better attacking. So, out of that the nitro will be the best group to withdraw this NO2 will come number 1. So, first the nitro group will be the stronger one, then comes the CH2 aldehyde group, second option, then comes the ordinary hydrogen, then comes the CH3. So, this is the decreasing order of reactivity, and this is the increasing order of reactivity. First nitro group, that is the option 2 is the number 1, then comes the 4, then comes the 3, then comes the 1, that is option B is the right answer. Answer B is the right answer. So let's go to the question number 6. In the given reaction sequence, ethyl alcohol is reacting with an oxidizing agent permanganate in basic medium heated. It gives a carboxylic acid, salt will be formed, and acidification, you will get the acetic acid A. Compound A is acetic acid. The acetic acid treated with the thionyl chloride followed by the ammonia, you will get a compound B, that is a acetamide. Acetamide on reaction with bromine KOH, methylamine is supposed to form. So the options, that is compound C is asked here, and A is a methylamine, B is ethylamine, C is propylamine, D is acetamide. So the option A is the right answer. So in this reaction, the sequence of reactions are: acetic acid is oxidized to give the ethyl alcohol is oxidized to give the acetic acid. Then subsequently with thionyl chloride it becomes into acetyl chloride. Acetyl chloride with ammonia gives acetamide. Acetamide is undergoing a one name reaction called the bromine and the KOH. This is a popular reaction called Hoffman-bromamide reaction. The final answer, that is methylamine, that is the compound C is methylamine, that is the answer. A is the right option. Let's go to the question number 7. The question is, which of one of the following on heating gives unsaturated acid? So here the carboxylic acids are having the different the hydroxy groups on different positions, and one of this acid is going to give the unsaturated acids. He is asking which one of that gives unsaturated acid. Option A is alpha hydroxy acid, option B is beta hydroxy acid, option C is a gamma hydroxy acid, option D is delta hydroxy acid. So out of these 3 different types of the 4 different carboxylic acids, what happens here is when a carboxylic acid is having a OH on the alpha position, then the 2 such compounds will react and becomes into like this. One carboxylic acid, one alcohol will react mutually. This is called a lactide. This is called lactide. When hydroxy group at alpha position, lactides are going to form. When hydroxy group is on the beta hydroxy is there, the alpha hydrogen has some hyperconjugation. So therefore this OH will take away. Originally the OH will have some minus I effect outgoing property. Now this hydrogen having hyperconjugation, if it is having this companion, so these 2 will go out on heating. However, on heating all this reaction, just on heating without any reagent, and this OH will go and you will get a unsaturated acid in between the alpha carbon and beta carbon. This is called a alpha beta unsaturated acid. So this is the question asked actually, which one of the following acid will give alpha hydroxy unsaturated acid, beta hydroxy acid will give. If the OH is beyond the beta means it can be a gamma, delta and so on, then this OH and COOH mutually react within the compound. This is called 2 molecule, therefore it is called intermolecular esterification, that is intermolecular esterification. Here within the molecule, intermolecular esterification leads to give the formation of a cyclic amide is formed. This is called a alpha, beta, gamma, and then let us say one more carbon. So this gamma hydroxy and this one intermolecularly eliminates water, that is nothing but the esterification. This is called lactone. Similar type of reaction with a beta amino acids also will undergo reaction. When amino is at beta, you will get a cyclic amides. They are called lactams. They are called lactams. Cyclic amides are lactams, cyclic esters are called lactones. Gamma onwards, when you have a lactone. This is the theory. So, the question is asked on the alpha beta unsaturated. So, therefore, the beta hydroxy acids undergo this type of formation of the alpha beta unsaturated acids. So, the option B is the right answer. Let us go to the next question. Question number 8. In the given reaction, a ketone containing one side isopropyl, one side ethyl group is treated with trifluoroperoacetic acid. So, the compound X is formed as a main product, and X will be the, what is this X he is asking, and option A is an ester where this isopropyl side you got a keto oxygen extra, and in the B option you have a O to the side of ethyl. Ester is formed, but the ethyl side O is there. And in the C we have a isopropyl group and one side only methyl is there. The other side isopropyl and the ester is formed, but it is a methyl. So, the carbons are not coinciding in the C and D, but option may be the A, B may be the one of the option. In this reaction, what is happened? The reaction, let us see. It is isopropyl containing one side, ethyl containing one side, a trifluoroperoacetic acid is added. This peroacetic acid will break up into the minus sign plus, and the plus will be added here. The entire minus is added on the carbocation. Then you will get a O with the H, and a per acid is added here. Because of the strong minus I effect, what happens? This will take these 2 electrons and leave here. A deficiency is formed, and in the deficient oxygen, one of the alkyl group will have a migration. Which group migrates means out of the 2 groups, both have the same type of the chance, but according to the migration aptitude, isopropyl, that is a 2 degree one, is a better migrating group over the 1 degree. Therefore, isopropyl goes on to the oxygen, and later this hydrogen is converted into the ketone. So, a ketone with one side ethyl, one side O with isopropyl. This is nothing but an ester of the propanoic acid with isopropyl propanoate is formed. That is option A is the right answer. The reaction is a very famous reaction known as a Baeyer-Villiger reaction. Baeyer-Villiger reaction. It's a rearrangement, in fact. Baeyer-Villiger rearrangement or Baeyer-Villiger oxidation. So, let us go to the question number 9. In this reaction, a 1,2-diaminoethane, that is the ethylene diamine, is treated with a diethyl oxalic acid, derivative diethyl oxalate. In presence of pyridine, compound X is formed. The X will be. So, in this reaction, what is happening? Amine is a better nucleophile which replace the carboxylic acid both the sides we have a ester group here. So, in this acid derivative, the NH2 will replace the ethoxy group. It is allowed type of the replacement because amines are stronger bases than the alkoxy group. Therefore, it is replacing. So, both the sides you will get a cyclic amide formation. With a result, you will get a diamide. Within the compound, you will get a diamide formation. Both ethoxy groups will go out. A cyclic diamide is formed. That is nothing but the option B is the right answer. Let us go to the question number 10. In the given reaction, a long chain containing both the ends with a ethyl derivatives of carboxylic acids, it is a diester, treated with the sodium salt of ethanol. Sodium salt of ethanol. Ethanol is a very weak acid, in fact slightly basic also, but it is a salt. Ethoxy group is a strong base. So, in the strong base, the esters undergoing a well known reaction called Claisen condensation. Here the two ethoxy, that is esters in the same compound, intermolecularly react and gives a cyclic compound probably. So let us see the options A. Option A is a ketone containing ester, that is a beta keto ester. Option B is a hydroxy containing beta hydroxy ester. Option C is only a ketone. Option D is a diketone. So here what happens in the normal reaction, if you take, let us explain first what happens in the normal reaction. If I take two propanoic acids, when treated with the OET, let us take the one ethoxy group takes away the proton of the alpha proton of the ester, and you will get a carbanion. This will attack here. When once the O minus is formed, when O minus comes back, OET will go, a ring closure will take place here. If the compound is a attached one, then naturally what happens, a 5-membered ketone is formed. At this stage a ring is closed, but this will be an ester. So with reference to the ester, where is the keto? This is a carbonyl group, alpha carbon and beta carbon. So the beta keto esters will be the answers. Only thing is it is an attached one. Instead of separate dicarboxylic acids esters, we have taken an attached one. Therefore you get a cyclic beta keto esters should be the answer. So and therefore the option A is the right answer. Answer A is the right answer. And this is a originally called what, a Claisen condensation. A intramolecular Claisen condensation, is nothing but the taken as a Diekmann condensation. It's a nothing but a intramolecular Claisen condensation, has a specific name called Diekmann condensation. Let's go to the question number 11. In the given reaction sequence, a 4-carbon dioic acid, that is known as succinic acid or butane dioic acid, on reaction with heat, that is called, you can say, pyrolysis reaction, compound A is formed, which on reaction with ethyl amine on heating gives a compound B. What is this compound B is asked. Here we have a pyrolysis reaction of dicarboxylic acids like this. When oxalic acid is heated, you will get a carbon monoxide, carbon dioxide and water. These are the three pieces you will get when it is heated. When malonic acid is heated, one CO2 will be removed and you will get acetic acid. When succinic acid onwards, when you heat it onwards, the OH and H eliminates as a water and you will get a beautifully a 5-membered ring is formed with a anhydride. Onwards, that means if you take a 5-carboxylic acid also, this is succinic acid, glutaric acid, adipic acid, they all give this corresponding anhydrides without loss of the carbons here. It's only water is removed, but the 4 carbons are retained. This is what happening as a in this reaction, as a is formed. This A is treated with the ethylamine. In the ethylamine, N is a stronger nucleophile, therefore it replaces this one and insert in this reaction. Again cyclic compound is formed. You will get a cyclic imide is formed. However, it is having a ethyl group, so therefore N-ethyl succinimide is formed. If hydrogen is there, it is ordinary succinimide. N-bromosuccinimide, NBS is a well-known brominating agent. Here it is a N-ethyl succinimide is the answer. So we have a option B is the right answer, that is N-ethyl succinimide. Answer B is the right answer. So let's go to the next question, 12th question. In the reaction given as a benzene, C6H5 with hydrogen means ordinary benzene. Reaction with the compound X is on reaction gives the benzene containing a benzene CH2CO, that is a sort of benzoylation is taking place on the benzene. It is a Fidelcraft acylation reaction. For acylation, the best acylating reagent is acid chloride. then anhydrides, then esters and the amides. So the first two happens to be the best acylating agent, acid chlorides as well as the acid anhydrides. Options given is here, that is the phenyl acetyl chloride, let us say phenyl acetyl chloride and phenyl acetic acid anhydride, and both A and B is the answer. And the last one is a dichloro compound, that is benzol chloride, that is not the correct answer. A and B is the right answer, that is answer C is the right answer. So here what is happening, benzene is treated with the acid chloride of containing, or you can also take anhydride form. Either one you can take. In this case also this group will be inserted into this in the place of hydrogen. In this case also this will be inserted. So finally what happens is a Fieldcraft acylation on the benzene through a keto inserted with a carbon and the phenyl. So this is the Fieldcraft acylation reaction. So option A and B both are correct, therefore the answer C is the right answer. So let us go to the 13th question. On vigorous oxidation by permanganate KMnO4 on a compound containing two methyls and a double bond, then we have again a ethyl group. This compound on reaction with the KMnO4, actually permanganate is an oxidizing agent. In different media it acts in a different way. In basic medium it is a weak or a mild oxidizing agent which converts the double bond into a glycol, but not cuts into pieces. But in acidic medium, that's what he says, vigorous reaction means it must be either a acidic medium or permanganate basic medium, boiling, heating also vigorous oxidation takes place. In this reaction, the reaction cuts into two pieces. If dye substituted are there, then it will become a ketone. Only one substituted means it will become a carbonyl compound, oxidizes to acid. Actually propanaldehyde will be formed, which is in turn oxidizes to propanoic acid. So therefore the combination acetone and propanoic acid, if it is there, that is the right answer. So the option A is a hydroxy, and that is a glycol formation shown, that is the wrong answer. Option B is a acid and acid, two acids, wrong. Option C is a alcohol and alcohol, that's wrong. Option D is the ketone and acid, that is the right answer. So let's go to the 14th question. Propanoic acid treated with chlorine red phosphorus, A is formed, A on reaction with alcoholic AOH compound, B is formed. What is B? This is asked in the IIT-JEE in 2002, and the options are given. It's a propanoyl chloride, option B is propanaldehyde, option C is a alpha beta unsaturated acid, option D is a beta chlorocarboxylic acid. Here the compound is a propanoic acid treated with the chlorine and the phosphorus. This is called a HVZ reaction, in which alpha halogenation taking place. It is known as what a Hell-Volhard-Jelinski reaction. In this reaction, one of the alpha hydrogen get halogenated. So the reaction becomes into a alpha chlorination, takes place at alpha carbon, then followed by alcoholic KOH. This is a strong base which eliminates the Cl. In addition with hydrogen, that side hydrogen is not there, only this side is available, so therefore this HCl will be removed, minus of HCl. Therefore alpha beta unsaturated carboxylic acid, or it is also called as a acrylic acid, commonly known as, that is nothing but the carboxylic acid containing ethylene is formed, that is option C is the right answer. So let's go to the 15th question. The rate of the reaction of a particular reaction RCOZ when treated with a nucleophile. The nucleophile is replacing the Z and you are getting a RCO nucleophile, and the Z will be out, eliminating outgoing group here. So, in which condition the nucleophile readily replace the Z, then the rate of the reaction will be fast. So, the options are given. The faster when Z is the option A is chlorine, option C is OCOCH3. If Z is Cl, it is called acid chloride. If Z is B option OCOCH3, it is acid anhydride. If it is O ethyl, option C is ester. Option D is amide. So, in this reaction, the order of reactivity is acid chlorides are the best reaction, followed by the anhydrides, followed by the esters and the anhydrides. Better will be the outgoing group, then the reaction will be fast. See, the outgoing, the order is first chlorine, halogen, R, then followed by the OCOR, then followed by the OR, then followed by the NH2. So, the order of reactivity goes on decreasing order of reactivity, this is called. So, therefore, the first best outgoing group is the Cl. So, therefore, the faster reaction is expected with the option A.